Hey everybody. In this video what we're going to do is we're going to talk about basic differentiation. So I have three functions here that I want to differentiate using the material from section 3.1. So if you haven't already, make sure that you have looked at section 3.1 and you're okay with what's going on with the derivative of a constant, a line, addition, subtraction, constant multiple, and the power rule, because I'm going to be using all of those in this video. So here we go. Let's take number one and let's differentiate. I'm going to be using a lot of ddx notation in this chapter. So just get comfortable with it. All that means is that I want to take the derivative of what comes next. Now the first thing I can do using the addition subtraction rule is I can break this into derivatives of the different pieces. So I'll take the derivative of 14x to the 7th minus the derivative of 3x to the 5th plus the derivative of 2x plus 1. Now, this is great. I have these numbers in front. I call these multiplicative constants. These are the coefficients of these power functions here. And by the constant multiple rule, we can bring those out. So this is 14 times ddx of x to the 7th minus 3 ddx of x to the 5th. And for right now, I'm going to leave the last part by itself. I'm not going to make any changes. All right, here we go. We can now use the power rule. So we have 14 times the derivative of x to the 7th. We bring that exponent down, 7x to the 6, and it's 6 because we're subtracting 1 from 7, minus 3 times 5x to the 4th. The derivative of x to the 5th is 5 times x to the 4th. Again, that's the power rule. Plus the derivative of a linear function. Well, the derivative gives you the slope, and our slope here is 2, so that's 2. So simplifying this just a little bit, let me see, 14 times 7 I think is 98. X to the 6th minus 15 x to the 4th plus 2. I'm going to tell you right now that I'm doing steps here that are as detailed as possible. I have shown you every single rule. Hopefully after a while you will get very comfortable with moving from here down to here by skipping some steps. So hopefully you'll see, oh, the 7 multiplies the 14, that gives me the 98. I subtract 1, I get the 6. But to start with, if you are just learning differentiation, I would encourage you to follow every single step until you get comfortable. All right, let's do problem number 2. Now, in problem number 2, we have an issue here, and the issue is that we've got some strange functions being involved here. I would like to use the power rule. In order to use the power rule, I need x to a power, which means I need to rewrite these expressions. So this is where all of your knowledge of fractional exponents and negative exponents is going to come into play. So the square root of x is the same thing as x to the 1/2. X down in the denominator is the same thing as x to the -1 power. So please notice, I haven't taken any derivatives yet. All I've done is rewritten what I had here, so everything looks like a power function. All right, I've got subtraction. I can split this up. Take the derivative of 2x to the 1/2 minus the derivative of 6x to the -1. Pull out those multiplicative constants, so 2 ddx of x to the 1/2 minus 6 ddx of x to the -1, and it's time to apply the power rule. So it's going to be 2 times, that 1/2 is going to come down, so 2 times 1/2 x to the 1/2 minus 1. I'll simplify that in just a minute. Minus 6 times -1. That exponent comes down. X to the -1 minus 1. So you can write this as, let me see, those cancel. That's going to be x to the -1/2 plus 6 times x to the -2. I am fine with the answer in that format. If you would like to convert it without those exponents, you could rewrite this as 1 over x to the 1 over x square rooted. So the minus sign flips it down. The 1/2 takes the square root plus 6 over x squared. But I'll tell you right now that I'm fine with this form right here. All right, let's figure out what's going on with number 3. First off, our variable is a t now. So instead of ddxing, I'm ddt'ing. Now, if we look at this, you go, none of this looks like power functions. How am I going to do anything with this? Well, again, rewriting is your friend. I can split this up as 7 over t to the 5th minus t squared over t to the 5th. It's the same denominator, so I can split up that difference. Let's do some rewriting here. That is ddt of 7 times t to the -5th power. Great, now I can use the power rule. Let me see, when these things cancel, I'm going to be left with t cubed on the bottom, so that's going to be minus t to the -3. All right, time to split it up. ddt, 7t to the -5 minus ddt, t to the -3. Pull out that 7. 7 ddt, t to the -5 minus, this stays the same, ddt, t to the -3. So I've got 7, -5, t to the -6, remember I'm subtracting 1, minus a -3, t to the -4. So that will be -35, t to the -6, plus 3, oops, that's a very bad plus 3, t to the -4. And again, for right now, this format is fine. So you don't worry about doing any more simplification or algebra. We have taken the derivative, we're done.